Well, we're already on to Chapter 13, which is about reliability and validity, and it is probably the most important chapter of this whole semester. Well, just what is reliability? Reliability is concerned with the consistency of the measurement technique. For example, if you use a scale to weigh a patient, that scale should indicate the same weight if the patient steps on the scale, then steps off the scale, and then steps on the scale again. Reliability is a measurement of the amount of random error in the measurement technique. Because all measurement contains some random error, reliability exists in degrees and are expressed as a correlation coefficient with 1.00 indicating perfect reliability and 0.00 as no reliability. A reliability of 0.80 is considered the lowest acceptable coefficient for a well-developed instrument and 0.70 for a newly developed instrument. This 0.80 rule is the one that I require. There may be some different numbers reported in your textbooks. Now, reliability is specific to the sample that's being tested. High reported reliability values in other studies does not guarantee that reliability will be satisfactory with a different population. Therefore, before any statistical operations are performed, reliability testing should be done. Reliability focuses on stability, equivalence, and homogeneity, and we're going to look at each of these in particular. Stability is an assessment of the consistency of repeated measures. It means when an instrument such as a survey is given one time to a group of people and then given to the same group of people a second time, that the results will be the same. It is called test-retest reliability. The assumption is that the factor to be measured remains the same at the two testing times, and any change in the value or score is a consequence of random error. A high correlation coefficient between the test and retest indicates high reliability. The problem with this method is that many traits do change over time, such as attitudes, behaviors, moods, knowledge, physical conditions, and can change the results on the test. Another problem is that the test taker can remember some of the answers on the test and will probably result in a falsely high correlation. On the other hand, people may find the test boring, taking it a second time, and take the test haphazardly, resulting in a falsely low correlation. In summary, test-retest reliability coefficients tend to be higher for short-term retests, less than 1 month, and lower for long-term periods of time between the retestings because of changes in the actual attribute being measured. Equivalence is focused on comparing two versions of the same instrument or two observers measuring the same event. Interrater reliability is an assessment of the agreement between measurements made by two or more observers who have measured the same event. And you can see where it is used a lot in our observational methods of collecting data to see if that's reliable. For example, you're doing a study on bonding between neonates and mothers, and you have defined bonding with a specific behavior. The study would include an observation of the mother-baby. In other words, there is a judgment made about the existence of bonding. This is ripe for bias. Therefore, a second observer must be utilized to determine if there is an agreement that bonding does indeed exist. Usually not every event has a second observer, only a percentage of events are monitored. Any correlation below 0.80 should be looked at with concern about the credibility of the data. A better score would be 0.90 correlation. Homogeneity addresses the correlation of various items within the instrument or the internal consistency, is determined by split half reliability or a Cronbach's alpha coefficient. This is primarily used for paper and pencil tests and addresses the correlation of various items within the instrument. This is used instead of testing groups a second time. An early testing procedure was called the split half reliability, where the test items were split in half, the two tests were given, and a correlation procedure done to determine if there was a correlation. Usually, the items on the tests were split in half by using all even-numbered items and all odd-numbered items. However, there's a problem. The longer the test, the higher the correlation. Therefore, a Spearman-Brown formula is used to compensate for this factor. However, different splits of the tests will produce different correlations. Therefore, they decided that a Cronbach's alpha coefficient was a better way to determine reliability and thus has replaced the split half. This procedure gives an estimate of internal consistency for all possible ways of splitting the test. The values range from 0.00 to 1.00, and the higher the value, the better the internal consistency. Usually, a coefficient of 0.80 to 0.90 is considered to be the best. Well, we've looked at reliability. Now, what is validity? The validity is the extent to which an instrument reflects the concepts being examined. Validity refers to the degree to which an instrument measures what it's supposed to be measuring. When a researcher develops an instrument to measure hopelessness in patients, how can we know that it is measuring only hopelessness and not only depression? There are also no formulas or equations that can easily determine the validity of an instrument. However, there are sources that supply evidence of validity that we're going to cover. Now, we need to look at the relationship between reliability and validity before I go on. You should ask yourself the question, can an instrument be valid and not reliable? No, an instrument cannot be valid without being reliable. An instrument that is erratic, inconsistent, and inaccurate would be measuring too many other factors associated with random error to be considered a valid indicator of the target population. However, an instrument can be reliable without being valid. Suppose we measured anxiety by measuring the circumference of wrists. We could get a highly accurate, consistent, and precise measurement, but such measures would not be validly measuring anxiety. Now, there are several types of validity, and we've got 2 slides worth to go through. The first one I'm going to discuss is content validity, and it refers to the extent to which the instrument contains all of the major elements relevant to the concept being measured. One way of obtaining content validity is to send the instrument to a panel of experts on the variable being measured. The panel has at least 3 members, and each is asked to evaluate each item on the instrument as well as the instrument overall. The members rank each item on a scale of 1 to 4, 1 being not very relevant to 4 being very relevant. The content for the total instrument is the percentage of total items rated by the experts as either a 3 or a 4. A content validity index score of 0.80 or better is considered to have good content validity. Now, the second one we're looking at is validity from contrasting groups. Now, keep in mind the word groups. There are groups of individuals who have extremely contrasting scores on an instrument are chosen to participate. The instrument is being administered to both groups. If the scores are significantly different in the expected direction, then the instrument has evidence of validity. For example, if we chose our group of students who had to pass an exam with a score of 98% to even remain in nursing school, and a group of nursing students who just passed the NCLEX, and then we measured both of those groups using a questionnaire on anxiety, the first group should score significantly higher on the instrument than the second group. So then it would have validity because the scores obtained from the group will be very different. Then there is validity from examining convergence. A researcher develops a new instrument, and then a group of individuals are asked to complete the new instrument and several other established instruments that measure the same variable. For example, a new instrument might be developed to assess for depression and compared to Beck's depression inventory, which is a very well-established instrument. Then statistical procedures are performed to determine a correlation. If the correlation is high, then there is said to be a degree of validity. Then there is validity from examining divergence. This is where you have one group of people, let's say, that they feel out of control. You develop a new instrument for feeling out of control, and you find another instrument on feeling in control. You give both of those tests to the same group of people feeling out of control. They should have higher scores on out of control and lower scores on the questionnaire for being in control. And if there is a negative correlation between those instruments, it would be said to have an extent of validity through divergence. Well, there's also validity from discriminant analysis. In this case, the researcher develops an instrument to measure anxiety, then gives a group of people the new instrument measuring anxiety and another instrument that measures a closely related variable such as fear. If the new instrument can tell these two variables apart by their scores, then it is said to have discriminant validity. Then there's validity from predicting future events. This tests whether scores on an instrument can predict future events, such as the GRE scores predicting the ability of a nurse to successfully complete graduate studies. Then we have validity from predicting concurrent events. This is a test whether scores on one instrument will be able to predict a score on the test of a similar variable. And finally, there is successive verification of validity. This means the more times an instrument is successfully used, the more information is obtained about its validity. Well, all of the different measures of reliability and validity that we've just been talking about actually pertain to studies that are done on non-direct measures such as attitudes and feelings, etc. When we're looking at physiologic measures, there are some different terms to be used. Now you got to remember, reliability and validity of physiological variables tends not to be reported in published studies. The assumption is that routine physiologic measures are valid and reliable. Such things as recorded blood pressure is considered to be accurate. However, think about that a minute. Anyway, accuracy is comparable to validity in psychosocial instruments. It is the extent to which an instrument measures the physiologic variable under study. For example, arterial blood gases are more accurate than pulse oximetry. The other term I want you to remember out of this list is precision. Precision is the ability of the instrument to reproduce the same measurement consistency. This is akin to reliability in our psychosocial instruments. Selectivity, on the other hand, is the ability of the instrument to identify the variable under study and distinguish it from other variables. For example, the instrument picks up electrical signals from the heart and can distinguish them from skeletal muscle electrical signals. This is done by contacting the experts in the lab. It is equivalent to content validity of psychosocial measures. And finally, there's sensitivity. This is related to the ability of the instrument to detect small changes in the variable. For example, a bathroom scale is not able to detect changes in ounces of weight, only pounds. Therefore, it is not very sensitive. Now, there are several sources of error for physiologic measures. There can be variations in operation of the machine. You might not have calibrated the equipment, and there can be variations in recording of values or errors. Well, how are validity and reliability reported in your article? It is usually done in the methods section of the research report, which we've already been working with when we were finding variables. The discussion is usually brief and lists the title of the instrument, a definition of the concept or construct, and a sentence or two about the reliability and validity of the data. As far as reliability is concerned, they should tell you, in a really good research study, what the reliability reports were for previous studies and for the study being looked at for the reader. Validity is usually the least reported. If you get a sentence or two about validity, you're very lucky. Sometimes they'll actually name the type of validity and sometimes not. So for this class, when it comes to reporting validity, and they have even mentioned it, you will assume that the instrument that the researchers have used is valid. This ends our lecture on reliability and validity.